Yo, what's up, guys? Welcome back to the podcast. This is a conversation with Alex Grant. He's an expert in battery supply chains, so this is super exciting. He previously studied chemical engineering and philosophy at McGill, and then he went on to co-found Lilac Solutions, which is a startup that's extracting lithium from the Salton Sea. They've been backed by Bill Gates and a ton of other firms, and I really like that startup. After Lilac Solutions, he went on to found Jade Cove Research, which is publishing and consulting in the battery supply chain. So he's definitely the expert on this. If you're interested in Tesla's battery supply chain, DeepGreen polymetallic nodules, which I've made a few TikToks about, or just you're a young engineer and want to get into the battery supply chain, this is definitely the podcast for you. So without any further ado, let's get into it. Oh, and also this starts in the middle of our conversation. Of course, the full conversation is on Spotify or wherever you get your podcast, so feel free to check that out. And of course, comment your thoughts. Let me know what you think. So yeah, let's get into it.
Now is the time to take risk.
So your experience is direct lithium extraction. You're making the memes about this. So what's your main thing that you want to get across about direct lithium extraction?
So I would summarize my professional thesis that I try to communicate through research articles and memes or whatever as something along the lines of like, let's actually take a step back and think through the kinds of environmental impacts that we are occurring and will occur in the battery value chain build out, mostly the upstream. And so I'm mostly focused on in the mining industry and chemical manufacturing industry and consulting across it with respect to lithium extraction technology. So kind of one of my keen interests is unlocking kind of new brine resources, which could potentially result in very low environmental impact of extraction to make battery chemicals.
And so you're more bullish on brine versus hard rock. Could you kind of explain the differences and why you're more bullish on, or why you're focused on brine?
So I think multiple types of lithium resources will feed the battery value chain in the next 10 years. And just to give anyone listening a little bit of background on this. So lithium chemicals that are used to make cathode materials in lithium-ion batteries, like those found in your Tesla or other electric vehicles, it's kind of the dominant battery technology platform now. Those lithium chemicals are principally made from two different types of natural resources. So the first is a mineral, like a solid crystal called spodumene, that is mostly mined in Western Australia. So it's dug out of the ground, upgraded to remove things that are not spodumene, that do not contain lithium. And then a concentrate is sent to China, where it is processed into chemicals like lithium carbonate and lithium hydroxide.
And is that the hard rock, or sorry, go ahead.
That's hard rock. Exactly. Yeah. Colloquially, it's called hard rock, but there are other hard rocks that can produce lithium, like lepidolite and pedalite and zinnwaldite and others. So I think it's fair to call all of those hard rocks. But the geology word that you would use is like a pegmatitic mineral, and that refers to the way that the resource is formed geologically. So that's where about half of
I was going to ask, how is that formed? Volcanoes?
It's so basically, so I'm not a geologist, okay?
Totally
So don't quote me, but basically lithium doesn't like to bind with other minerals fundamentally for kind of physical chemistry reasons. So if you have a pocket of magma in the earth, the lithium will tend to segregate to the top.
It's the lightest element.
Because it's light and due to some of its chemistry. So it'll segregate to the top and concentrate. And then when that pocket of magma kind of cools, it'll eventually form a pegmatite vein or dike, which is a technical mining term. So pegmatite and spodumene is about half of lithium production today. And then the other half is from brines. And the brine is just a salty water. So the lithium is dissolved in nature in a very high salt content.
Much higher than the standard ocean.
Much higher than the ocean. So the ocean is 3.5% by mass salt, mostly sodium chloride and calcium. These lithium natural resource brines are typically between 10 and 30% salt.
Okay.
So 3 to 10 times more salt than the ocean, and much higher lithium concentration. So the ocean has 0.2 ppm of lithium in it, which is a very small quantity of lithium. These brines will have kind of tens to hundreds to thousands of ppm of lithium.
That's a huge
totally
difference.
Different.
And that's why you're always like, lithium is everywhere, but it's not easily extractable everywhere.
Yeah, there's a heck of a lot of lithium in the world, right? The ocean is the biggest lithium resource in the world, right? Lithium in the ocean. But the question isn't like, do we have enough lithium? The question is, which type of natural resource should we develop to extract lithium from, using which technologies, right? And the technology is a variable that can change, and it does change all the time. Right, there are a number of different approaches to make lithium chemicals from natural resources that will incur which environmental impacts, right? So how do you quantify environmental impacts? And that's something I spent a lot of work on doing life cycle assessment with some really smart folks in London called Enviro. And at what cost, right? So what will be the operating expense of liberating lithium from a mineral or making it concentrate from a brine, and then eventually converting it to lithium carbonate or lithium hydroxide. So it's this incredible complex phase space, right? That requires input from geologists and hydrogeologists and environmental experts and chemical engineers and chemists and mechanical engineers and market experts, and all these different skill sets come together to answer that question, right? That complex question.
For sure. So then why are you bullish on brine? Just to pull the thread on that.
So I don't strongly favor brine necessarily over pegmatitic hard rock minerals. I mean, fundamentally, they're all just matter sitting in nature. I mean, I don't like one more than the other. But before I kind of answer that question and like kind of the trade-offs between them, I'd also add that there's a third category of resources, which is sedimentary clays. So from Oregon all the way down to Mexico, there's kind of different deposits of dirt, really. So it doesn't look like a crystal or a mineral. It looks more like a sediment, and it flows. And if you put it in water, it breaks up. It's a very different kind of geology.
And this was in the news because of Tesla.
This was in the news because of Tesla, because they report to be developing their own sedimentary clay project in Nevada. But there's plenty of activity in Nevada focused on sedimentary clays now. It's just there just isn't any commercial production from sedimentary clays yet. But by 2030, there probably will be, almost certainly. So in terms of what is my favorite resource, right? I wouldn't say I have a favorite resource, but what I do prioritize and what I do value and what I do think is important is minimizing the environmental impact of lithium chemical manufacturing from natural resources, period, right? Because the lithium market's going to explode by 8 or 10x in the next decade, right? I mean, it's just like 90% of it doesn't exist yet. Right, it's tremendous growth that is happening really right now, and it's happening because of EVs, right, and because of the electrification revolution and the energy transition, right.
So I think I read somewhere that 30% of the lithium that will be used by 2030 hasn't been developed yet.
The majority of lithium values coming out of natural resources today, in 2030, the vast majority of that lithium doesn't exist yet. Those projects have not been built. Those mines have not been dug. Those brine fields have not been developed. Those wells have not been drilled. So there's a tremendous amount of moving around large quantities of material ahead of us in the next decade, and there's a whole bunch of folks working on that. The mining and chemical industries. So to kind of answer your question, so I think it's important that the energy transition works, right? We're doing this to avoid catastrophic climate change caused by accumulation of carbon dioxide in the atmosphere, right? Like we're not anti-CO2 emission even, right? We're anti-CO2 accumulation. We can't let it accumulate. The concentration can't build up because that's what causes the greenhouse effect. So in that respect, we have to make sure that the supply chain of manufacturing those batteries is decarbonized as well, right? Because there are natural resources being developed now that have never been looked at before, such as sedimentary clays and other types of brine and other types of pegmatites that are lower grade and higher in purity than the types of resources that used to be processed into lithium chemicals, kind of, if infinity time ago is 20 years ago. So yeah, very different. The energy transition has created a transition in the way we develop natural resources. And there are environmental impact kind of factors to that. There are technology development and deployment factors to that. And I think it's critical that we're monitoring and understanding all of those kind of developments that are happening simultaneously, so that we really understand it and kind of ensure that the energy transition is worth it, right? Like, if I'm making lithium hydroxide in China and emitting some exorbitant quantity of CO2 because I'm burning coal, or whatever it is, then it doesn't matter if the lithium atom in the Tesla in Norway right, isn't
For
emitting
sure.
CO2 in Norway, right? Because
Mhm.
the atmosphere, it's we all share this atmosphere, right? The boomers, the Gen Z, the squirrels, the humans, the whales, right? Like we depend on the common atmosphere, right? So yeah, the CO2 molecule doesn't care where it's emitted.
So you're mostly focused on making sure that the new technologies developed are decarbonized or lowest carbon impact. So do you focus on brine because it has the most potential to reduce the amount of carbon emitted per amount of lithium?
So historically, back in ancient times, like a year ago, since I since I started kind of consulting independently across the lithium industry, I was kind of more focused on brines because fundamentally, in a brine, the lithium is already in solution, whereas in a pegmatitic hard rock, you actually conventionally have to calcine the spodumene at 1,000 degrees Celsius first in order to get the lithium out to get it in solution. Right. So there's a thermodynamic barrier that needs to be overcome. But my work has evolved to looking at how do we decarbonize mining of spodumene as well. Right. And the reason why is because a heck of a lot of spodumene mines will be built for a variety of reasons that are geopolitical and environmental and cost based. And so I've realized, it's also super important that we decarbonize spodumene mining because it's going to happen. Right. Like I accept reality. Right. And I want to meet reality, right? And do whatever I can to help people decarbonize their processes and their minds and understand the options and the trade-offs, because that is also critical. So I wouldn't say it's like either or. I would say that all different types of natural resources are being developed to make lithium chemicals, and we should decarbonize all of them.
So when you were discussing the hard rock, you said that it had to be heated up so that it frees the lithium. Now, this also is similar to geothermal brines, right? Where you need the higher temperatures so that the lithium is easier to be extracted, from what I understand. I'm just vaguely asking about geothermal brines.
Yeah. So I would say those are kind of the heat in both cases has fundamentally different functions. So if you're using a calcination and a roasting to liberate lithium from a spodumene concentrate, you're doing that because that is literally the quantity and type of energy that needs to be put into the kind of material system in order to liberate the lithium. In a geothermal brine context, and just to kind of, at a high level kind of explain, these are brines that are taken from between 3,000 to 10,000 feet deep, and they're typically between kind of 50 to 150 degrees Celsius after heat is taken out to produce electricity using relatively mature technology developed in California and around the world. So the Salton Sea has a geothermal brine field just south of the Salton Sea. There are actually north of the Salton Sea too. There are geothermal energy plants all over the place. And what those plants are doing is they're taking brine, so salty water, from between 6,000 and 8,000 feet deep and potentially a bit lower in some cases. And they're producing the brine, high pressure and high temperature. They're flashing off steam. So when you reduce the pressure, steam comes off of the brine, and that steam can be used to produce electricity. And then after that brine, with all the salt in it, has produced steam which produces electricity, it's mineralized, right? It's salty, and it's relatively salty compared to other brines, actually. That brine actually does have lithium in it, and it has zinc and manganese and iron and silica and a whole bunch of other things too. But there are currently a number of real commercial projects focused on trying to get the lithium out of that brine in the Salton Sea right now. And I think at least one of them will probably succeed. I'm not going to name names, but I think at least one of them will succeed. So that's a really interesting concept, because first of all, you're producing low carbon power simultaneously as you produce lithium chemicals, right? So that's attractive in the sense of, the energy transition that we're undergoing right now. But it's also attractive because the footprint is so small, like the physical footprint on the surface of the earth, right? Like you have a chemical plant with a basically a stream of brine flowing through it. You use a direct lithium extraction technology, which is the use of a kind of engineered material to selectively remove lithium from the brine and then leave everything else. And then you're putting it back underground. Everything that's not lithium, you put back underground. That is the concept.
And you don't add many materials to it or chemicals? Or
in some cases, you do need to modify brine a bit. And I won't go into details of exactly what you need to do. But there are some components of the brine that can cause issues for some technologies. And that's not a rule, right? It is a trend, I would say. But based on my observations, brine chemistry modification is probably needed in most cases. So that's the idea behind geothermal lithium. I think it's a really interesting idea. It's interesting to note though that like a geothermal, like there is literally no geothermal lithium on the market today. It doesn't exist yet, right? So this is a mid to high TRL, technology readiness level.
What is okay?
Technology approach.
Okay.
So,
So is it because it was a new technology approach, or why wasn't this available before?
So two reasons. So first of all, a number of new technologies have been developed and really improved significantly over the last 5 to 10 years, which enable geothermal lithium in some cases. That's the first part. But then the second part is that we just didn't need the lithium, right? But before the lithium ion battery kind of story, right? Lithium was used to make glass and lube and kind of I don't want to be mean to glass and lube, but they were just small,
a ton of things. Yeah.
It was a very small industry, right? We didn't need 3 million tons per year of lithium carbonate. We only needed 100,000 tons per year. So this is kind of like a textbook economic geology transition. So I'm going to try to visualize this graph. I don't know if you can add it later or something, but like on the x-axis you have lithium concentration in a resource, and on the y-axis you have quantity of lithium stored in a resource at that concentration. Like I was saying earlier, most of the lithium in the world, a lot of lithium in the world is in the ocean, right? And so there's a ton of lithium in the ocean. So at a really low concentration, there's a huge amount of lithium, and then only at a couple in a couple little instances, like the Salar de Atacama in Chile and some other salars and the Greenbushes mine in Australia, you have really ultra high grade resources that are kind of freaks of nature, right?
Okay.
And where do you think the humans kind of started extracting lithium?
For
right?
sure.
Obviously, they identified where the freaks of nature, right? The highest lithium concentration resources, because it's easiest to get the lithium out of them. It's cheapest too, right? So what happens though when you increase demand is you've tapped all the high lithium concentration resources, right? So you've got to start going down the axis. And I don't know if this is materializing correctly on the screen, but
for those watching the YouTube video, you can see him doing the graph.
So as you need to produce more and more lithium, and you kind of tap out and cannot produce any more lithium from the freaks of nature, you have to start developing lower grade lithium resources. Right.
So geothermal brine has less lithium concentration than these other places, but we're starting to do it. So does the grade for geothermal brines, is it significantly lower, or why are we extracting it now? And will this be one of the faster growing resources? The reason that I'm asking this is I have a ton of young engineers that are probably looking to start a startup eventually, or join startups. Where should they be looking to jump in on the supply chain? I think geothermal tackles these two things by producing energy and lithium. So that's really great.
Yeah. So first, so 3-part answer. So first of all,
3-part question.
If any of your listeners, 3-part question for a 3-part answer. If any of your listeners or viewers want to learn more about the space, there's a ton of free information on my website that they can access and learn from and play around with. There's a heck of a lot there to kind of get you started on understanding the lithium industry. Cool. And if they are particularly kind of energetic and have some interesting questions or ideas, please feel free to reach out. It's super easy to reach me on Twitter and LinkedIn and email and different avenues. And so yeah, if you have anything interesting that you want to share, feel free to reach out. And if you're looking for a job or thinking about a startup idea or whatever it may be, I'm all ears and I'm here to help because again, I believe in young people, and I believe that young people have a lot to bring to the space. So that's the first thing I would say. Second thing I would say is to answer your kind of technical question about brine resources. So are geothermal brines low grade? Yes, compared to kind of conventional, historically developed brines. So, like the Salar de Atacama in northern Chile has, probably the wells that are pumping brine as we speak are pulling something like 1,500 to 2,000 ppm, parts per million, of lithium brine. That's very high. That is exceptional. And I'm pretty sure that's the highest lithium grade brine on the planet, at large scale at least. And so let's call that 2000 ppm. There's been a lot of development activity, and by development activity I mean commercial projects, like people are actually trying to build mines and chemical plants. There's been a lot of commercial activity on Argentine brines, kind of on the other side of the Andes, and a lot of those brines have concentrations in the range of 300 to 800 ppm. So we've already gone from 2000 ppm, 1500 ppm to about half to a third of that in Argentina.
30%, yeah.
And some of those projects use DLE technologies, or one of them uses a DLE technology in their process. It's kind of like a hybrid DLE technology that also kind of leverages evaporation. And other new projects will use DLE technologies because they're just lower grade resources, and the evaporation in Argentina is typically less than in Chile. The Atacama Desert is the driest place in the world. So evaporative lithium brine processing doesn't work as well in Argentina. It still works, and some projects will be highly successful using evaporative techniques, but it's not as robust and as reliable as it is in Chile. It rains more in Argentina. So that's your second question. And then to answer your third question, which is like, where should people be looking for jobs and looking to have impact in the lithium industry or the battery metal industry, or really, I would propose to think about kind of all of industry, right? Because some of the decarbonization problems that are related to technology in chemical processing are just, they're chemical processing issues, not necessarily lithium processing issues. And I think a good example is high grade heat, right? So if I need 1,000 degrees Celsius in processing of something, right, whether it's a kiln and I'm roasting a rock or sediment or whatever, historically that was met using fossil fuels, right? And today it is met using fossil fuels. And in the future, it will still be met largely using methane, right? And other hydrocarbons. I think one of the really significant technological priorities of decarbonizing industry, whether that's chemical manufacturing or mining or kind of these sectors that I spend most of my time in, is heat, electrifying heat specifically. We need to find a way to take in, high voltage DC power and convert it to 1,000 degrees Celsius air, right? Okay. And make that heat transfer work well and solve a number of problems associated with electrifying heat.
So would that be an electrical engineer? How does that process work? Or
yeah, so electrifying heat. So if I tried to scale up electric, like rotary kiln, like an electric rotary kiln. By the way, I'm not an expert in this. Let me just say. So
that's totally fine. I mean, these are the new fields, right? So
I might sound stupid, but hey, I'm not afraid to sound stupid every once in a while. So there's probably issues with heat transfer from the source of the heat to the material inside the kiln. There's probably issues with material of construction of the heating elements. So I'm not familiar with all of the heating element options for heating something up to 1,000 degrees Celsius, but you can imagine if I need 1,000 degrees Celsius inside a rotary kiln, that's basically a long tube that rotates, then I'm probably going to need slightly higher temperature, or maybe a lot higher temperature, kind of in my heating element that's a part of the kiln or on the outside of the kiln or something like this, right? So I don't have 1,000 degrees Celsius materials construction problem. Maybe I have a 1,500 degrees Celsius materials construction problem, right? So again, I'm not an expert in electric calcination.
You don't know the answer. You just know that this is a problem.
I don't know the answer, but I do know the question.
Yeah. No, honestly, that's great. That means that it's ripe for a startup.
100%. And I would also say, I think it's crucial to work with industry players too, if you're trying to scale up something new. Like if you're really in ideation research phase, don't try to talk to big companies because they might just try to steal your idea. Like prove it out in kind of mini pilot scale first, for sure. But when you really start to hit on something that appears to be valuable, having friends in the industry that you're trying to disrupt or participate in is invaluable. It is so important to have a good network in the industry that you're trying to participate in. And that's where the boomers kind of have an advantage, right? Because
I was just gonna say that's where LinkedIn comes in.
That's where LinkedIn comes in.
We need to start 100%. The Twitter DLE space. We need startup Twitter, there's tech Twitter. We need DLE Twitter. If you are listening to this and you have DLE comments, please tweet them. Please tweet at us.
Just don't give me a blue check mark. Like the day I get a blue check mark is the day that I am calcified and I should just be
For sure.
like
That means you're
disposed of
at the end of your career, for sure.
I should just graduate to something to Facebook or something. Yeah, I mean, we did talk about Facebook, right? I mean, I think you'll agree with me. Nothing happens on Facebook now, right? I mean, Facebook is like a wasteland.
Yeah, I never use Facebook.
But
So I know you have a hard cap at 11:30 your time. So before we kind of wrap up, I wanted to ask you what, I got a lot of questions about this. I've previously made videos on DeepGreen, and recently it was discussed that they're looking for a SPAC with SOAC. And I was just wondering, have you looked into DeepGreen? Do you know much about their lithium extraction or their materials extraction? For context, they're mining polymetallic nodules at the bottom of the ocean floor. What do you think about this potential acquisition or company?
yeah, so I'm a little familiar with DeepGreen. I know some of the folks who worked on their project. I don't have any contact to DeepGreen, so my perspective on this is very kind of virgin and just internet contact. What I am interested in what they're doing, I would say, and just for context, so they're trying to like suck up these kind of like rocks of manganese, nickel, and cobalt at the bottom of the ocean, the Clarion-Clipperton Belt in the Pacific, kind of equatorial Pacific, kind of west of Mexico. And I'm interested in this because obviously we need the nickel and the cobalt. I think they're mostly manganese. I don't remember, but we need manganese, but maybe not all the manganese. So I don't know how exactly they're going to market their manganese. But my main contact with them was reading their life cycle assessment. So they put together a very professional LCA report, which they published, and I think it's available online, where they quantified their environmental impacts using best practice methodologies. And I think that was important because there's been kind of conversations around the risks associated with deep sea mining, right? Sucking up these nodules from the ocean floor, which potentially brings along with it, other sediments or things that are potentially alive that could kill those things that are alive. So I think the LCA that they produced was very professional and supportive of their kind of thesis about what they're trying to do. And so if it's between sucking up nodules from the middle of the Pacific versus tearing up rainforest in Indonesia or New Caledonia, right? I really don't have anything against deep sea ocean worms. I swear I don't. Right? I think it is extremely important and valuable that we study their biology and their physiology and identify like, are there compounds in their skin that we can turn into medicine or whatever it may be. I'm super attuned to that reality, but extraction and producing these materials that end up in our lithium-ion batteries and our Teslas, or wherever we want to use them, your cell phone, et cetera, always carries environmental impact. Let me say that again. Production of materials that go into your batteries, whether it's your electric vehicle or your phone or whatever, always has environmental impact. The point is not to eliminate the environmental impact, because you can't. You literally cannot, right? The point is to quantify and control and reduce the environmental impact. It is a minimization function. It is not a multiply by zero function.
For sure.
Right.
So this is a great way to reduce the environmental impact.
So according to the LCA,
it looks like it. Yes.
So if I was to say this in what I think are the best technical terms, according to their LCA, for the impact categories that they quantified with the consulting company that they did it with, there are impact reduction opportunities for deep sea mining compared to tearing up rainforest in Indonesia.
Okay.
In terms of biodiversity and other impact categories. So
totally agree.
So I don't think anyone cares about my approval of what they're trying to do or not. Maybe someone does, but what I would say is like, that is the right way to approach this question is to quantify and understand and compare, right?
Totally.
Because just because it's new doesn't mean it's bad. And I think it's really problematic that they faced a lot of resistance just because it's new and just because it hasn't been done before. I don't know what like planet
people are scared of the ocean, mining in the ocean.
People are scared of mining the ocean. And I don't think that is a super mature position. I think it is a mature, smart position to say, let's study the biology of the animals that live in the deep sea ocean. 100%, like literally everyone's on board. But just being objectively against ocean mining, I think is not the most mature, kind of best way to think about it.
For sure. So I have one last question. I kind of wanted to get more into your background, but But in lieu of that, that would take a little bit of time.
I can push my call back by 15 minutes.
That's totally up to you. I
Yeah.
had really two questions. I kind of wanted to talk about your background, how you started, Lilac, and you were a chemical engineer and philosophy major, and then you started Lilac, and then you started Jade Cove, and what the future of that looks like. And then I guess if you push your call back, I'll save that question for the last one. But before that, I wanted to ask also, other than this electricity to heat problem, what is the other $1 billion, like, what's your like wish for
What are the other
supply chain?
questions? Other questions I'm asking. Yeah. Okay. So my story at a super high level. So I am from the country north of Toronto, about an hour north. I grew up kind of in like playing in mud in the fields, building forts and diverting rivers and collecting rocks. And so it actually was surprisingly formative. And I graduated from high school and then went for my undergrad in Montreal at McGill, where I was going to study physics and philosophy. And someone's mom was like, "What are you going to do with that?" So I switched to chemical engineering and philosophy. So I did, that was my major and minor. And throughout undergrad, I was doing academic and industrial research in wastewater treatment and water chemistry. And so I've been studying kind of water related processes for my entire adult life, like a decade, basically. And I kind of got tired of cleaning up other people's messes. So I went for a PhD at Northwestern in Chicago to study CO2 conversion heterogeneous catalysis. So this is the idea of using kind of special materials that make CO2 plus hydrogen reactions move much faster to make certain products. And so I thought I was interested in this concept of the solar fuels kind of cycle, where you would use something like methanol or DMO or formaldehyde in a kind of new kind of engine and combust it with oxygen and release CO2 and then capture it again, split water to make hydrogen and oxygen, re-react it and repeat using renewable energy, presumably. But and that was really fun. Like I built like a high pressure, high temperature reactor and a gas chromatography machine, and I learned so much about physical chemistry and analytical procedures and all these things that I still use today. It was very helpful. But I realized that the solar fuel cycle was probably not a good way to store energy for ground transport. Lithium-ion batteries in electric vehicles is 1,000 times better, and that applies to the hydrogen fuel cell concept too, by the way, if anyone wants to Google what I've said about hydrogen. Yeah. Just had to share on hydrogen a little bit. But anyway, so I left my PhD, well, to back up, I was hired in grad school to run a seminar series that was put on by the engineering PhD students for the business school, pretty much. Mm-hmm. I mean, anyone was invited, but it was like mostly like Kellogg MBA students who didn't know anything about technology or energy technology or anything.
Of course.
And I was hired to take that over from a graduating PhD student who was finishing his PhD in material science. Named Dave, super brilliant guy, very insightful, and I started chatting with Dave about where the lithium was going to come from for manufacturing all these batteries for electric vehicles, and he basically invited me to meet in the library in grad school, and this was in like 2016, so this was 5 years ago now, and he told me a bit about some ideas he was having around lithium extraction. And he essentially asked me if I wanted to work on it, and I said absolutely. This is fascinating. So that project that really started in 2016, and it turned into Lilac Solutions. So I left my PhD with a master's to help start Lilac, and yeah, so that became Lilac, and Lilac raised a $20 million Series A announced in February 2020. That was led by Breakthrough Energy Ventures, which is Bill Gates' climate fund. So that was kind of my entry point into lithium and mining, and that was an opportunity where that was a place where I taught myself a lot about a lot of things, right? Mm-hmm. So we were like a 4 person startup at the start, right? So I was the only engineer really, and so I built all of these kind of automated systems to demonstrate the technology, which is requisite for proving the value proposition of the technology. So I taught myself like how to program like PLCs and how to do kind of basic electrical engineering, like nothing sophisticated at that time. I'm sure it's evolved since I left. But I taught myself a lot of stuff around like physical chemistry and hydrometallurgy, which is really like aqueous phase mineral processing, and it was a lot of fun, a lot like sleeping at the lab a bunch of times, making sure the robots were doing what they were supposed to do and taking samples and stuff. And very, very early stage startup kind of.
It's a common theme.
Aesthetic. Yeah. Well, when it's got to work, right? You sleep at the lab. That's what you do.
Yeah.
So that was my time at Lilac, but I I really wanted to have a broader impact across lithium and across battery metals and beyond. So I left actually almost exactly 2 years ago to kind of start my own company, consulting across lithium. And part of what I did over the last 2 years was develop a really deep global insight into all the different types of direct lithium extraction technologies. And so that research and that understanding and that kind of first principles informed insight has created a lot of value for some of the folks I work with. So I'm super proud of that. And a big part of also what I've been doing over the last 2 years is I mentioned Minvaro in London a little while back, is working with them on life cycle assessment. And I'm working with this really smart guy named Rob, who did his PhD in LCA of mining in the UK. And we've been doing life cycle assessments in the lithium industry for projects in development. So these are folks who are trying to build lithium mines or lithium brine extraction projects or lithium processing facilities, and they want to understand what are the hotspots in their environmental impact kind of profile, right? And so what are the top 3 or 5 things that drive their CO2 intensity or water use or whatever it may be. So we build a life cycle assessment model which informs them of where they kind of need to look to mitigate those impacts. So my kind of mission is to build the best battery supply chain possible, because we deserve that. The world deserves that, right? Like we owe it to the people buying electric vehicles to do that, right? And I really feel like Pro is really operationalizing a really important part of that, which is to quantify and understand environmental impacts. And then kind of part 2 is, well, okay, I have an impact because of technology XYZ in my process. What are alternative technologies that I could use to perform that function in my process, right? Mm-hmm. So this kind of brings me to your second question, I guess, right?
What's the golden fleece?
The interesting opportunities, in my opinion, are those which reduce environmental impacts, right? So whether that's reducing CO2 emissions of a process like electrifying, or other schemes for, I'm just kind of like brainstorming off the top off my cuff here.
That's the best
way
to do these.
Basically other schemes to produce low-grade heat that don't require fossil fuels, right? Anywhere that diesel or methane or coal or oil or any fossil fuel is used in a process or a mine, identify what are the opportunities to remove it from the process, right? That's the algorithm. That's the objective function. So that's a big part of it, and then water is a big part of it too. So in mining and mineral processing, you always use fresh water, always. Anyone who tells you that they don't use any water in their process either doesn't understand their own process, or they don't understand it yet, or they're lying. It's one of those two. And so it'll always use water. So the goal is not to use no water, because it's pretty much impossible in almost all cases. The goal is to minimize the amount of water we use, right? And potentially use maybe brackish water instead of fresh water, for example, things like that, right? Because like a brackish water which has maybe 0.5% salt instead of fresh water which has 0.1% salt, right? Like you can't use that brackish water for agriculture, or animals probably aren't drinking it in most cases. And like if you can sub out fresh water for brackish water, right, that's an improvement in terms of the process's impact on water availability for animals and people and agriculture and plants, right? So CO2 and water are really the main kind of pain points in lithium processing and in all mining and mineral processing. So things which reduce CO2 emissions and which reduce water use are valuable. And we could use some more breakthrough technologies on both those fronts. And yeah, again, if anyone wants to reach out with ideas or questions on that, happy to chat. I'm always happy to kind of help energetic, motivated young people with interesting ideas to succeed, because so many people have helped me along the way, and it's really a pleasure to be able to kind of give back and really start giving back as soon as I can.
For sure. So it's not like a holy grail membrane, but that's where can they find you on Twitter? How can people find you online?
First of all, I would just say, like, thinking in terms of holy grails is not the right framework. Like there's a lot of like little step change improvements that are useful. So yeah, so always be skeptical of people who are talking about holy grails, because usually they're kind of full of shit. But that's what I say. So how to find me on the internet? You can find me on Twitter at Alex Jade Cove, and I guess you'll probably like internet this somehow. But I'm findable on Twitter. you can find me on LinkedIn, and you're welcome to reach out or add me or whatever. And my email is on my website, so I make it as easy as possible to access me. So
For sure. Awesome. Well, Alex, I appreciate it. I'm definitely looking forward to seeing how Jade Cove plays out, and hopefully we'll have you on the pod next time again, and definitely looking forward to it. I appreciate the time.
Thanks for having me, Jack. Yeah, we're gonna have to talk someday about terraforming the Salton Sea, because I am so interested in this as well. You can either dry it up and control the dust along the way, or somehow put more water in it, right? And who's really good at doing things like that? The mining and chemical industry, right? So we'll have to we're gonna have to put some more thoughts towards that.
We're gonna have to do a podcast of
project.
brainstorming terraforming the Salton Sea.
Yeah, we should just invite a bunch of funny rando technologists and just shoot the shit on how where's the water going to come from. We can't, the Colorado River is tapped out. That's not an option. So yeah,
well,
another day.
My idea with the clouds, but you have to make sure that they rain.
We were talking about this, right? Because there's evaporation ponds just northeast of there where they're making industrial minerals. So I really don't think they would be happy if you seeded a bunch of clouds to rain.
And you were off by just a few miles.
And you were off by 100 kilometers or whatever it is. You're gonna eat into someone's profits eventually there. So
for sure. But maybe there's a mechanism to control the accuracy of making it rain. Who knows? I need to look into that more, but we'll have to do a podcast on brainstorming that. Either way, I really appreciate the time. All the links are in the description. Go follow Alex on Twitter. Go follow me on Twitter, NASJAQ__, and I'll talk to you guys later. Okay, cool. Thanks, Alex. Bye.
Bye.
Awesome. So I hope you guys enjoyed that conversation with Alex Grant. Definitely go check him out on Twitter. Check me out on Twitter at NASJAQ__. I also just finished recording a conversation with an anti-aging or longevity expert. That was super fun. So be sure to subscribe for the next one. Like, comment, let me know what you thought of this one, or if you have any guests that you'd love to see on the podcast. I know I made a few episodes and then I kind of paused, but I'm definitely coming back to the podcast. So looking forward to it, guys. I'll see you in the next one. Peace.